Yeah, well, thank you. Thanks for having me here today for this event and for you guys showing up. And, you know, there's a lot of good speakers that you have lined up. Let me move this so it's not in the... And it's nice that it's going to be streaming later. But anyway, as Patty said, I don't know if many of you guys, if your residents here are familiar with the Wave Glider or Liquid Robotics based out of Hawai'i, but it's an autonomous robotic vehicle that Jupiter Research Foundation developed. We developed in 2006, 2007, and then we developed primarily because we were listening to humpback whales off of a moored buoy, and that moored buoy would break anchor and go off all the time, and we were sitting around one day and said, wouldn't it be nice if we could develop an autonomous robotic vehicle that could hold station, and we didn't have to go through a million permit processes like the Army Corps of Engineers, because you're anchoring to the seabed and so forth. And so one of the guys' sons has worked in robotics and started playing around in a fish aquarium and then a swimming pool with a popsicle stick, and sure enough developed this vehicle. And I'm not really going to go into the whole structure of the Wave Glider and what it is. If you go to Liquid Robotics or Jupiter Research Foundation, their website, how it works, you get to see it. But you're going to get to see a little bit here. So I was one of the co-developers of the Wave Glider and helped launch Liquid Robotics out of Hawai'i, managed them for 3 years and came back to Jupiter and wanted to develop it in a way to study humpback whales, as that's my primary focus since I started studying humpbacks in Alaska and here in 1980. So I wanted to get this Wave Glider developed a little bit more robust so we could send it to other places. We've done 4 missions, and I'll talk a little bit about those a little bit later so far. And this mission, this presentation today is about the last mission that occurred in 2021. The following is a little 2-minute little video that I did, I don't know, a couple of years ago that kind of goes into a little bit, so I just inserted it here. And here's that map of Hawaii. Aloha, my name is Beth Goodwin with the Jupiter Research Foundation. We have been partnering with Whale Trust and others over the last few years to send Europa, our Wave Glider equipped with a hydrophone, into mid-ocean basins east and west of Hawaii in search of possible unknown presence of humpback whales. Over the years, Europa has traveled well over 12,000 nautical miles in over 350 days, and collected over 6,000 hours of audio data. Throughout the years, we have continually improved the audio quality, eliminating the need to filter out the rudder noise as seen by these 4 white bands. In 2018, we discovered humpback whale calls in mid-ocean basin between Hawaii and Baja California seamount. In 2021, we again deployed Europa from the Big Island to go eastward, but on a slightly different and further course towards Mexico. The 150-day mission, traveling 5,000 nautical miles, was a huge success, as once again, we heard humpback whale calls far offshore, validating our discovery in 2018. Jim Darling, myself, and my daughter Jessica and her baby Natalia have been analyzing over 1,700 hours of audio data. We have heard all kinds of sounds from minke whales to various odontocetes, as well as some really strange sounds we can't identify. The baby, by the way, now 5 months old, settles right down whenever she hears whale calls. Once the analysis is complete, we look forward to publishing and sharing our results with you all. Mahalo. So the baby now is almost 3 years old, and she has a little sister, Gabriella. And I tell you, whale sounds off of a Wave Glider is the best lullaby you'll ever hear, because it's just that ocean. Anyway, that's just a second. All right, so this map shows Europa's 2018 and 2021 survey tracks. The dots are humpback whale detections. The orange line is Europa's 2021 track, recording track to Isla Clarion off of Mexico. unfortunately, during this mission, we had a hardware failure halfway across to Mexico and thought that we might lose all the data for the entire mission. But with a little bit of remote engineering, we were able to resume recording and restore or collect the audio data on that hydrophone itself. But we ended up losing about 16 days of audio, which is this spot from here to here. And it left us 30 days of recording left on the Ocean Sonic Smart Hydrophone. So some of the days we were able to record full days, and some other days we had to just record partial days. So, and I'll show you another graph that shows that. But we wanted to get what we could over here, and then we stopped it when we came back, and then we wanted to get this little section right in here again, so that we pretty much had a full thing. Okay, so this is a summary of the mission. Distances are of the Europa's travel from Hawaii to East Liquid are on the top. The black boxes on the bottom indicate when we recorded full, partial, or no days. The red and orange boxes are confirmed and probable humpback whales. The blue boxes are minke whales, which you can see are pretty much every day almost. The brown are unidentified odontocetes, and the brown with the black dot are sperm whales, and the yellow boxes are unidentified cetaceans. Note that we pretty much heard something almost the entire time, particularly minke whales. Likely, had we had more wave gliders out or been able to record every day 24/7, then those boxes would have filled in with something every day. And I kind of wanted to point this slide out to you as a little bit of a segue to something else. It's a whole different talk that I'm not really prepared to talk about today. But many of you know that there are plans to do deep sea mining off of the Clarion-Clipperton zone, which is between Hawaii and Mexico. And they claim that it's basically a desert with very little inhabitants from the ocean surface down to the bottom. So there would be minimal to no long-term impacts. And while this topic, again, is a whole different subject, there's plenty of papers that have done a little bit of work out here and refute that they can't really claim that, including us. I wanted to show you Europa's survey track in relationship to the Clipperton-Clarion zone. It's hard to see here on this map, but the Clarion, the CCZ fracture zone is right here. And we just went through the very top of it there, but we pretty much heard whales the entire time. So this is a little segue, but I wanted those that we're reading about it in the papers now, and you can kind of hear about it. And we plan to submit our data. The paper is published, and see what they say. All right, back to the results here. These are spectrograms of humpback whale calls detected 1,000 miles offshore compared to the calls off of Maui the same year, 2021. You can see that several of the notes are actually completely identical. You know, there's an academician, Dr. Jim Darling, that worked on all this and did all the comparisons. I wanted to make sure I did all the listening. I wanted to confirm that he was actually hearing the exact same things. And there were days when we thought that we were hearing multiple whales in one time. So these three colors represent three different songs going on at the same time. So it wasn't just a one whale by happen chance. This is a 1-minute recording off Europa when she was 1,000 miles offshore, playing some of the same sounds that we saw in the spectrograms just above. And the little squiggly lines that you see here and there, that's of a minke whale, and it'll sort of sound like a boing. So you'll hear them here. Like I said earlier, we've done 4 missions. The first one was 2018. We went towards Baja California Seamount, and then we went west towards the Marshall Islands, and then we went in 2020 through the Papahanaumokuakea Marine National Monument, and then 2021 we went back west again, east again, trying to validate if what we heard in 2018 was an anomaly, a one-time event because of all kind of other situations, or were we really hearing whales? Even the one we went through the Northwest Hawaiian Islands, we were able, while we all knew there were whales there, that was not an unknown, we were able to send the wave glider in much closer than the NOAA ships are able to get in because of their draft. And we were able to go into atolls and places that they hadn't been and heard with abundance, not just onesies and twosies. All right, so Dr. Bruce Mate and his colleagues from Oregon State University have been tagging humpback whales for many years, tracking their migration route between their feeding and breeding grounds, as indicated by this map here. These are actual track lines when the tag didn't fall off, for instance. And you can see that the whales tend to go pretty much in a direct, straight line from the breeding or feeding ground to the other. They don't tend to just come down and wander all through here, and then go. They kind of go straight. And, but none really tended to go below latitude 40 degrees north and 140 west. So none of his tagged animals tended to come down in this area. And this is where we decided to send the wave glider, is what's happening in here,
What's that area called again? I'm sorry.
Pardon me?
What was that area called again?
The clipper.
The box.
The box when I showed it before,
Yeah.
It was the Clarion Clipperton fracture zone, the CCZ. So what we learned is that with the wave glider going west and going east with these blue lines, these are whale detections. This is where we heard the whales. And nobody had even thought to survey there because they're not there. So it was kind of a whole novel idea to do this. And it literally was pretty much like searching for a needle in a haystack, if you will. The wave glider's 10 feet long by 2 feet wide, a submerged part that's at minus 22 feet, and it's just one thing that can kind of pick up sound within 3 to 5 miles or so. And so for it to run across a whale, it means there was probably a lot more whales. All right, so a few of the whales have been documented actually that go between Hawaii and Mexico, or Mexico and Hawaii. In fact, in 2018, there was a match in the same season. So in the same winter months, it was in Hawaii and it showed up in Mexico, or vice versa. It was in Mexico and showed up in Hawaii within January, February, March. So we know that happens, but we don't know how often it happens, even though fluke IDs are starting to tell us that it happens more. I don't know what that is. There.
Do you know what the time frame difference was between
I do. It was like 35 days or something. Or actually, there's been some that have been shorter. Okay, thanks for doing that. Oops.
Okay, can you just touch it and maybe the next thing will come up?
It's not one of the next. There's another one you can zoom in. Okay.
That's spacebar?
Huh?
Oh no, I just hit
Okay.
the clicker.
Just to show them.
Okay.
Yeah.
Okay. Of the tagged whales, like I showed you on that previous map, none went down to that lower latitude. Given that the hydrophone detects humpback whales within 5 to 10 miles, and at best out to 60 miles away from Europa, either we got really lucky on the course that we sent Europa on, and unbeknownst to us, we ended up sending Europa on the exact track in thousands of miles of open ocean that it was going to run across the handful of whales that it ran across, which seems really unlikely to me.
Yeah.
Or more likely, there's a distribution of humpback whales across a much wider latitude band between Hawaii and the West Coast, and Europa really only detected a small percentage of these that were within range. But in either scenario, we have no way of inferring direction of travel or number of whales present, because the wave glider was only one. We weren't doing triangulation. We don't know if there were females, calves, or subadults, since only the males are singers. And since the males were singing song, we know that the song probably plays a very significant role in social and spatial coherence in vast open spaces. So probably more of a role than we thought here in the breeding grounds. So these tropical offshore humpback whales that we discovered could be within season migration or between the Hawaii and Mexico breeding grounds. They could be an offshore breeding assembly in of it themselves. I mean, other baleen whales, filter feeding whales, do breed out in deep blue waters, not just come close to shore 600 feet shallower within close to the islands. The minke whales were out there the whole time and they're breeding. Could be an unknown migratory route. Maybe more happens between the two breeding grounds than we're aware of. Could be grounds for song exchange. You guys probably know about the humpback whale song that's kind of throughout the entire breeding Pacific grounds from the Philippines, Hawaii to Mexico. It's the same song. Maybe they're meeting out there part way, changing the Louie Louie a little bit, and then going, okay, you take that back. Now that didn't work so well over here. You want to swap that out. We don't know, or some other crazy explanation. We just don't know. But regardless, more research should be conducted to confirm these findings and should be part of future discussions for humpback whale population distinctiveness, abundance, and behavior, as well as deep ocean resource management, such as the deep sea mining. The docuseries, Earth Sounds from Apple TV got wind of us. They were doing a whole docuseries called Earth Sounds, Listening to the Earth and all of its sounds. And they did a little docuseries on us. It's on Apple TV. We're in episode 12 called Listening to the Planet. However, I watched the entire series, 1 through 12, and it is fantastic. And I didn't have Apple TV, and I shouldn't say this, but you can do a 1 month free. And then it's only $10 a month. I missed the one, I didn't do it the 1 month, so then I did 2 months. But anyway, it was well worth it. The whole docuseries just phenomenal. So here I just wanted to touch on something just slightly different. I have a nonprofit, Jupiter Research, not Jupiter, Eye of the Whale, and I collect fluke IDs, and I have them categorized on the catalog there from 0% to 100%. And I just wanted to show you 0% are pretty much all black. And I have them, 0 to 10, 10 to 25, 20, but here I'm just going to give you, these are 50 to 75%, you can see. And these are pretty much 100%. And the reason I wanted to show you this is there's a organization called Happy Whale that maybe you've heard of, but if you're out on the water at all, you can take pictures of these whales as citizen scientists and log in and create your own free account with Happy Whale and submit the picture. They'll have guidelines. They prefer not the 500 yards away iPhone picture, but I will tell you, the algorithm that Ted Cheeseman has come up can identify that whale. Anyway, this is just my website, my number of whales that I've done, but I was out February 25th or something, down here off of Kealakekua with a girlfriend of mine, and we're going snorkeling. I didn't bring my big camera, I didn't bring anything. I bad girl. I had my little iPhone, but I ended up taking a picture with my phone, and lo and behold, this whale. This is me down in. This is this whale down in off of Kealakekua. This whale's been seen off of Russia and Mexico.
Wow.
Not in the same year, but it kind of goes to show. This isn't the migration route. This is just. But by you contributing, and anybody that contributes to Happy Whale, it can help us learn more about these migrations in the same year kind of stuff. So, thank you.
Can we do it with past years?
Any year, there's been data put in there since, like I've submitted my data. There's people that have been submitting data back from 1980 something another.
Yeah.
You know, so you can take your, and no, it's showing up like some of my, I call them my whales, but
Yeah,
you know what I mean. From 2007 are matching to some people that submitted whales in 1984.
Wow.
There weren't that many people taking fluke IDs prior to the 80s. We didn't really know that the ventral side of their flukes was unique, so there weren't that many people doing it prior to the 80s. But once people figured that out, there's people submitting Hilo and southeast Alaska. The place that I work is in Alaska is Prince William Sound. Anyway, yeah, go back as far as you want. So.
You mentioned that you could differentiate a little bit between minke whales, humpback whales, and other species, but that sometimes it was difficult. Are there certain sound patterns that you listen for, or things that?
Well, minke whale is very distinct. It has those three little squiggles, you know. And when you sit there and you've listened to 7,000 hours, you kind of get, humpback whales are a particular low frequency. So we actually didn't sit there, we watched the spectrogram and you look for the certain kind of squiggles. Fin whales was kind of the low, there's blue whales, but we were not really trying. Sperm whales, we could tell the clicks, the coda clicks. Those I could pick up. Odontocetes are higher, you could pick up their clicking, their echolocation. But because we had so many hours and we were focused on humpbacks, we only selected once every 2 hours a minke whale. Otherwise, we'd still be analyzing the minke whales. But you can pick up. Now, AI is trying to get where it can detect this so that you don't have to by human. But off of the wave glider, there's enough other sounds, surface noise and rudder sounds and this and that, even though we quieted it really well, that it tricks the AI. And so it's still, at this time, has to be done by human eyes. And then we took turns between the three of us. If I thought I heard something, I'd make Jim double check it. And if he thought he heard something, he made me double check it. And then we said, okay, it's a definitive humpback versus probably a humpback, but we're not going to call it out.
Fascinating. That's amazing. How did you, anybody else have questions?
So years ago, when I lived in Santa Cruz, I was a member of the Monterey Bay Aquarium, and I used to go down there for talks. And they were tracking. They were trying to figure out the breeding zone for the great whites, and they lost them somewhere about 700, 800 miles southeast of the Big Island.
Yeah.
It was a dead zone because they didn't have the satellites weren't there to figure out where they were going, and that's why I asked you about the Clarion area, because it looks like it's in that same area.
I didn't pull the slide up here, but when we did the 2018 mission, we actually, it's called the Great White Shark Cafe.
Oh, right.
We sent the wave glider through the Great White Shark Cafe, and it becomes like your little baby. So I was up for 3 weeks, 24/7, thinking, because we do have bites. We do have bites where they've bitten the fins on the bottom or bitten the float, and I was just afraid they were gonna, because they're attracted to electrical pulses. I was afraid they were gonna just bite the umbilical and just, even though we had a wire thread member in there that would be hard, but they can bite through anything.
No,
And we were gonna lose the data. So part of these missions, especially the beginning, the 2018 one, is we had an engineer and software developed so that we could capture wave files, big sound files, and then we had them converted into little MP3 files, and then we had them sent back through the cloud, 10-second files 6 times a day. So that if the wave glider got run over by a vessel, or got eaten by a shark, or picked up by somebody, I could, at least in those 10-second files, if by miracle I heard a humpback whale at 12,000 miles offshore, I would say, okay, at least we heard them. And we did. We did, in those 10-second files, hear some humpbacks. And we had the ability to stop the wave glider and tell it to stroll around right there and take a little more listen. And the wave glider itself is quite an astonishing.
You guys have remote access to that.
We have remote access.
Wow.
We could pilot it. So I was a pilot. We piloted off of our phone, off of a computer, 24/7. It also had automatic identification system, an algorithm for AIS, for ships that have automatic identification system, where if a ship was coming towards it, it would steer away from it until the ship passed, and then it would get back on its course and keep going to keep a ship from running over it. And if a ship had picked it up, we would know, because it's not that easy to unplug it and tell it to stop transmitting its transmitted position every 5 minutes. For it to stop transmitting its position, whoever stole it would have to know how to do that. And we had alarms set up on it so that it suddenly it travels at 1.5 knots average speed, with a current 4 knots against a current less. If suddenly it was going 30 miles an hour, or 10 knots, we get an excess speed alarm, and we look it up and see exactly where it is, and, so, anyway.
Have you lost one?
Me at Jupiter, we at Jupiter have not. Liquid Robotics has. In 2019, when we were going to the Marshall Islands, we had one. I was actually giving a presentation in Maui at Whale Tales on the mission, and I was up there on the podium, and I get, when the thing's in the water, my phone's with me, I'm like a doctor, I carry it all the time. I'm up there on the podium giving a presentation, and I get an alarm that there's sub-to-con floats error, which is a fatal error. And so I finished the presentation, go look at it, and there had been, the umbilical had been compromised, and it wasn't communicating anymore, and it went into it has a rudder that steers it. It went into right rudder, so it was doing circles. Anyway, long story is, it kept sending its location every 5 minutes, and in about 6, we thought, well, where's it gonna wander? It was no longer steering, currents only. Finally, we flew out to Majro in the Marshall Islands, took a vessel, not a very big vessel, 750 miles offshore, and found it, and picked it up and brought it back. So I have not lost one. Because the data that it had was, we didn't know, we wanted to hear those whales. And sure enough, that map that I showed you before west, we heard whales where nobody had even thought to look at.
Yeah, when you said desert zone, like, it's a pretty big ocean out there, but I'm pretty sure there's no desert zones out there.
Well, that's where the metals companies think that it's a desert. I mean, there are areas, the metal company was saying it's a desert zone. That's why they could do this deep sea mining. Now, I've worked on NOAA ships where we're doing line transects, and sure enough, when you get closer to lands, you pick up more marine mammals than you do when you're out there in the middle of nowhere. It is, there are less. It's not, but there's not none.
No.
Yeah. So.
Interesting.
Did you ever try to study between sanctuary zones, like humpback sanctuary zones and non, and find that would you find more sound there, or?
Well,
meaning that maybe they were going there because they were more.
Sanctuaries, the humpback sanctuary zones are pretty much around the areas where there's higher incidence of humpback,
I
that's why
see.
they're being
I
protected.
see.
That's why the zone was made,
Okay.
is because humpbacks tend to go, and do go, it is true. I don't think that there's as many humpbacks out there in the middle of nowhere as there are around the Hawaiian Islands, close to shore. They tend to want to breed in protected areas, and closer to land masses along the coast is more protected than out in the middle of nowhere. However, we don't know, because blue whales aren't coming, or minke whales aren't coming close to shore and breeding, and I don't publicize this to certain countries that like to hunt minke whales, but there are zillions of minke whales out there.
Yeah, keep that one under your nose.
I mean, the sound, oh my God, it's another minke whale. I mean, that's another minke whale.
Shut up.
So it was like, oh, I didn't realize. And their song, by the way, from the east, central, and west, the minke whale's boing changes. And so we were able to pick up the difference and where that change starts to happen.
Interesting.
Yeah. And this previous speaker, who I just mentioned a little bit to her before she left, Rachel, she talked about microplastics and macroplastics. We actually built a microscope and put it on a wavefighter and sent it out, and we were able to detect and pick up, had a little suction tube that sucked up the microplastic, put it through a microscope, a little plate, took a picture of it, and then AI was able to detect that there was something versus just water. Sent us a thumbnail shot back in real time. And we did this one time in Monterey, next to one of the Monterey research vessels that took the bucket over and dropped it down and hoisted the bucket up and took the water jar and took it into the lab and put it in, got the student to put it in and put it in, got Mike to put it in. You know, and then so we can only do one right now. It takes about 2 or 3 months to get the others, and we called them up because the wavefighter, well, there was diatons and there was, because we got the picture instantly back, and they went, wow, okay.
Wow.
But funding ran out, we didn't get to develop that, didn't happen, it's a shame.
So you're capturing so much information.
There's so much that
Everything.
these wavelighters can actually capture and do. For me, it was all about the marine mammals, but there's so much more they can do.
Any
Great.
other questions?
Yeah, and forgive me, we arrived a little late, so you may have explained this, but in the zone, the transect of your study, you captured humpback whales starting near the Big Island and continuing all the way, but no tagged humpbacks were labeled there, right?
We know that tagged humpbacks were what?
But you didn't see any tagged humpbacks, right? The routes you showed us of the tagged humpbacks were not there. So, do you have any information or any theories about why you can start hearing them near the Big Island, but none of the tagged ones are going?
Well, it's
I'm
just,
a little thrown off by that.
yeah, okay, let me go back to this. Let me go back to this map, this one.
Perfect, yes.
Okay, so, we don't know if Oregon State were to tag, these are the locations where the tags were deployed,
Okay.
okay? Let's say they were to tag 100 whales here and 100 whales here, or 500 whales here and 500 whales here, would we maybe not see their lines going here?
Yeah.
But they just have, of the ones they've done, none actually did this.
So are those tracks individual whales?
These tracks are individual
Okay,
whales
so
that
it's a
have
small
the
data
tag
set.
on them.
Okay, so it's a small data set.
It's a pretty, but they have more, this was up through 2016. There's another one through 2020 something another, but even that one doesn't have any coming down here. So part of, I've talked to Bruce and Dan Palacio, can we make a more effort? Well, can we send NOAA ships out here in the first place? We know where to go. We've done it twice, but it's to go out January, February, and March. I've gone out on NOAA ships. They tend to go July through November, not during the winter months because it's nasty out here. Nobody wants to be out here when it's really nasty. But if we could get out there, then we could maybe see more in person and do biopsies and get photo IDs and who's who and how many and da da da. But if they could do some more tagging in these two, in Hawaii, not just off the Big Island, and see if more goes across. What is helping us decide, because of happy whales and taking the fluke shots, the more occurrences, we've got 3 or 4 only, so it's not like it happens all the time, but there's not that, you don't get every whale when you're out there. But if there was a huge effort to spend 3 years doing a gazillion fluke shots here and all the fluke shots here and seeing how many went back and forth. So it's just there's a few different methods to doing it. The concrete one would be to send a ship out there because you'd get it, first time you went out, you'd get a good idea.